Oh, hi. So in this recording, right, I'm just going to explain you about some data warehouse concept, right, which is minimally needed if you are going to present saying in your interview, like you have some data warehouse knowledge. Maybe you are not working in any data warehouse platform earlier, but you can say uh, you when you are working in the big data platform, you got to know about some data warehouse concepts, okay? Because like you have worked in migrating some data warehouses to your big data platform. Regardless you are from data warehouse background or not, you can just mention some concepts which is really needed, right? When you explain in your interview. So this particular recording will show you how you can talk about some data warehouse concepts and how you can explain you have enabled these data warehouse concepts in Spark. Okay, altogether that is the concept behind this particular recording. Okay, so the evolution of OLTP to OLAP happened because of the evolution of database to data warehouse happened. Maybe when we were teaching, when we start about the complete teaching, right, we will talk about how the evolution of big data have happened. But in that one, you can see the evolution of OLTP, that is a database to data warehouse, have happened earlier, right? So in such a way, if you consider OLTP, it is all about online transaction processing, right? Any transaction that happens in the end system or in the kind of a point of sale system, right, where you go to a shop and purchase something, that could be a transaction, where you can see a huge volume of transaction happens, where a quicker data processing will happen. The concentration will be more in terms of processing the data rather than analyzing it. The data will be stored in a normalized fashion. You know that, right? The sense like I store the data by splitting a wider table into smaller tables of more narrow tables. If I have all the data in one place, customer information, product information, geographical information, and the transaction information in one table, if I maintain, there will be a huge chance for getting duplicates, or I have a huge challenge of maintaining huge number of columns in a single table. That is not good for a transactional system, basically, right? So in order to have a proper transactional system, I will split the data into many tables. In this OLTP system, you can quickly find who bought this particular product, or I wanted to update some quick product information, or the sales information, or insert some transaction that happened. I will go to the transactional system, basically. But if you wanted to know about how many people have purchased a product in a particular date, or in a past 1 month, or in 1 year, we'll go towards maintenance of OLAP system. So OLAP can be achieved. OLAP is all about online analytical processing, which can be achieved by creating a data warehouse platform. In the data warehouse, you will be storing the warehouse of data. So in the transactional system, you will not store the warehouse. It is more about like you have a showroom and you are going to maintain a warehouse to maintain all the products in your warehouse. So if you maintain all this data, the transactional data on a daily basis into a warehouse, you can perform online analytical processing on top of it. Like the OLAP system will have high volume of data. You will write slower queries, in the sense like when you write a query, it may take very longer time to execute. Maybe it may take from seconds to minutes to complete, because it is going to consume huge volume of data. It is going to be mainly used for analyzing the data. Since we are going to write queries regularly, it has to be optimized, in the sense like the data, the way how it's stored has to be in a denormalized fashion. It should not be having a huge normalization applied, in the sense all the data will be kept in one or fewer tables. Maybe like you will have one table called cust prod trans. So it will contain the customer ID, product ID, transaction ID, and transaction information. If you want to expand and see some detailed view, you will have some other tables in the other side to maybe like get some additional information. That is how it will go with respect to the online analytical processing system. So we have something called fact and dimension in data warehouse particularly. Okay, so maybe the flow how it will go in terms of data warehouse will be like there are different stages are there, starting from data acquisition till the data analysis, right? Data warehouse have several stages. Maybe I can say if you have the data received in a file system, right, you may grab the data and keep it in a staging layer. Staging layer is all about a file system or a database. Temporary database tables, you may store the data. Then what you may do, 1 second guys. So I think like there is some disturbance I'm getting. Okay, so let me continue. I got the disturbances reduced maybe. Okay. So we have mainly two concepts in data warehouse. So primarily I told you have several layers. Okay. So I'm not showing that over here, but however, I mean, you can just think about it actually, like there are several layers like data staging layer, right? That is the primary part when the data will be acquired, or when you get some data from some source system, it will be kept in the staging layer for some period of time. You can consider like Kafka, or you can consider like HDFS file system. Like that, in data warehouse, they'll be using the database tables itself or a Linux file system itself for storing the data for some period of time, for the staging period. So after that, once the data is being stored in the staging, right, it could be taken to a layer called operational data store, ODS layer. Okay, so where you will have several warehouse tables will be created basically. That is called a warehouse actually, data warehouse, where I'll be maintaining maybe up to 1 year or 6 months worth of data. So why we have these layers, the staging layer main purpose is to keep the data temporarily for a day or a week, because if you want, you can just get those source data once again from that layer rather than going to the original source system. That is one part. So if you go to the warehouse layer, right, the operational data store layer, from where the staging layer, from staging layer, this operational data store layer will get the data, and in that ODS layer, you can see the data that is being identified with the keys or with the joined information from different sources, merging or data munging. All those activities will happen, and the collected data or the joined data or a kind of a primary consolidated data will be stored in that layer. Okay. The final layer is going to be the mart actually, like that is the place where the user will go and query to identify or to analyze the data. The OLAP activities will happen at the mart layer basically. So the ODS layer will contain all domain data. Maybe like it could have finance data, or it could have customer transaction data, it could have banking data, or even it could have sort of like product information. Like everything could be kept in one layer basically. But whereas in one place, that is called operational data store. But from there, the data will be divided into subject area, in the sense like all the finance data will go to a mart number 1. That's called that could be called as a fin mart. Some other mart may be created that will contain the transaction information. We can call it as a trans mart. So some other set of data will go to different mart layers basically. That is the final layer, where the other mart may contain fleet information. That could be a fleet mart. Like this, you can have some mart called big data mart. Big data mart in the sense, if from the data warehouse, whoever wanted to send the data to the big data platform, they'll store those data into the big data mart actually. Like this, it may have the final layer called data mart. Okay, so in the data mart, we will be having the tables, type of tables. These are all just tables only. Facts and dimension are all just types of tables. Okay, in that mart, we may have the fact and dimension tables kept actually. Like particularly in the mart, we'll have the fact tables. If you consider in this image, if you can see procurement fact and sales fact is there. So all the procurement information of different products could be kept in this one of the mart called procurement mart, which contains a table called procurement fact. Okay, maybe this procurement fact is going to collect the data from different the surrounding tables you are seeing, vendor, buyer, purchase order, all could be considered as a dimension tables. So what is a fact table? A table which contains factuals or measures. Those table is called as a fact table. For example, if you consider in our case, you can say the transaction table, what we used to use in Hive, could be a fact table. If you consider the customer table, or if you consider a product table, or if you consider a purchase order table, anything can be considered as a dimension, basically. So that dimension will contain, for example, if you take product table might contain product ID, product name, product category, product genre. These information will be kept in the product table, which is dimensions, right? So product dimension we'll call it as. For example, if the fact contains the product ID and the amount the product is sold for, the quantity, how many products has been sold and which date it has been sold, then we'll be keeping that in the procurement fact table. But if you wanted to know about, I mean, like which product has been sold, what is the category of the product, what genre it belongs to, then you can join the table called product dimension table with the procurement fact table to understand which product has been procured, or which product has been procured, which belongs to what category. Like those information you can enrich in a fact table by joining with the dimension table surrounding it. So this is the overall concept behind. So you can consider like facts are like a transaction table or a detail table. Dimension are all like a master table. This is the overall concept behind this facts and dimensions. Okay. If we just see here, this could be an example for the fact and dimension. You can see here, I have a fact table called fact revenue, right? In that fact table, I have maybe like billing date, salesperson ID, order date, customer key, marketing key. Like those keys are all kept here along with the amount, the value, right? So if you wanted to get more customer information, you will join with the customer table. That is a dimension table. If you see in the top, there is a customer table, right? You can join with the customer table based on the customer key, and you can enrich this fact table by adding more fields like name, type, first contact date, or segment ID, status code, or whichever the column you want to enrich. You can enrich by performing a join with this fact table with the corresponding dimension as per your need. Okay, so this is all about the fact and dimension. So if you see here, you have a centralized fact which is going to connect with several dimensions to enrich the fields as per the need. So this is the example for a fact and a dimension table. Okay, let us consider about something called star schema and snowflake schema. So this might be asked in the interview. If you go for a data warehouse interview and all, this is an obvious question. What type of schema your organization is using, or are you into star schema, or do you know what is a star schema? Like those questions might be asked. So star schema is nothing different. If you see here in this example, if you don't have a segment table in the left side, that means the customer is expanded with the segment table. Customer is a dimension table already, but we are having one more dimension table stored in the other side called segment. If you want to get the detailed information of the segment, you have to go and join customer segment along with the fact table. Otherwise, you can't get the segment information. So if you avoid that segment table in the left side, if you have only a direct connectivity with the fact table and the dimension table, we call that schema as a star schema. So if you will be understanding in the next example, when I talk about snowflake schema, you will understand what is star schema is all about. So star schema will looks like a star symbol. You can see here, right? One fact table will be surrounding with multiple dimension tables. Maybe one dimension table might not be expanded. You will be having only one dimension table actually. You will not have connected dimension table in case of star schema. For example, employee dimension, if I have, means I'll have all the employee information in the dimension table. You will not store the detailed employee information in another table. If that is the case, and if that is the case, if I go right, that represents you are going with the snowflake schema. If you see here, for example, if you see customer is a table which is a dimension table. The customer table is expanding to a customer type. So that represents you have you haven't stored all the customer information in single table. You are storing it in two tables. On demand basis, you may expand it. So this sales items is the fact table. Sales item is expanding with products, time, locations. But location is expanding. Location is a dimension table. Territory is a dimension table. Customer is a dimension table. Customer type is a dimension table. If you see here, the expansion of dimension table may happen in addition actually. That represents it is a snowflake schema. So you can see here, there is a concept called snowflake schema over here. So this is the two concepts what will be asked actually, star schema or snowflake schema. So you have to understand what is this star schema is about and snowflake schema is about. Star schema represents more of direct connectivity. Snowflake schema represents more of a chained connectivity. Maybe like in snowflake schema, you'll have multiple dimension tables connected to each other. In star schema, directly the dimension table will be connected only with the fact table. So this is the overall concept behind snowflakes and star. If we go to something called slowly changing dimension, the main part what we have to really see about, okay? In this example, I have given both the examples. What is the slowly changing dimension number 1 and 2? We have several types actually, like starting from slowly changing dimension 1, we have 2, 3, like this. We have different concepts actually. So I am going to mainly concentrate on 1 and 2 because that is the market used slowly changing dimensions. But first of all, what is slowly changing dimension? So the name itself says, you know what is dimension table now? Right? So you can see here, in this case, employee dim is a dimension, product dim is a dimension, customer dim, shipper dim, time dim. These are all the dimension tables. Okay. Several dimension tables are variable. That means several dimension tables maybe keep on growing, okay, or changing. Several dimension tables might not be changing. Several dimensions are fixed dimensions. For example, time dimension, if you take the left side, if you see, right, the time dimension will not be changing. For example, you will create the calendar for another 10 years or 20 years or even 100 years and keep that as a dimension table. That dimension table will not change at all. But whereas product dimension, you can't assure. Today a product might be available, tomorrow it might not be available. Or today a product might belongs to a particular category, tomorrow it might belongs to a different category. Like this, you can have the dimension table might be keep on changing. How do you manage this change in big data platform? That is what ultimately we are going to see. But if you see this particularly, if you see a product dimension table or any other dimension table, it may be keep on growing. For example, if we take that product as an example, for example, you have different types of slowly changing dimension. Type 1 represents in a slowly changing dimension. For example, product table I'm going to maintain. I will not be maintaining the history of the change that happened. For example, if you see in the left side dimension product, right? I have a product ID P1 with customer, the product name ABC, price of 10 rupees, and the packaging type is paper. If you have, this is the product value maintained for product ID P1 in a table. Tomorrow you are going to change this price from 10 to 20. That is slowly changing. Very rarely it may be changing. Not daily I may change the product price. So if you have such a dimension table, then we'll call it as not a SCD dimension. We'll call it as a rapidly growing dimension. There are different types out there, but mainly people used to concentrate on slowly changing dimensions. For example, the question might be, how do you accommodate this change in big data platform? Because the big data storage layer, wherever you are using, is not prone for changes. It is write once, read many. So once you have written with the price of 10 rupees for a product P1, how do you update it? This is the question what will be asked. Okay, either using SCD 1 or 2, whatever the type you are going to use, you may be asked with the question saying, okay, how do you implement SCD concept in your big data platform using Spark or Hive or anything else? So SCD type 1 represents, I don't want to maintain the history. If a product ID P1 is having a price of 10 rupees today, tomorrow it is going to change as 20 rupees. I want to replace this 10 with 20. So I'll be maintaining only one record for product P1. If this is the case, we call it as slowly changing dimension type 1. What is type 2 represents, you want to maintain the history. Maybe like if you see the second image in the down, type 2 maintains the history of your older value and the current value also. So that represents, if you wanted to go back and see what was my previous value, or if you are generating report for last month, maybe for the last month, the product price is $10 or 10 rupees, right? If you generate a report for how much sales have happened last month, if you wanted to see, right, you have to see with 10 rupees, not with 20 rupees, because last month the product price was only 10 rupees. I sold this product for about 100 products I sold, means I sold it only for 1,000 rupees. Now it doesn't mean like you sold it for 2,000 rupees last month. But this month, with version 0, if you see, right, you can see it is only 10 rupees. But this month, if you are going to see, you have to put with the recent value. That is version number 1. So in order to track the previous changes happened, in order to maintain that history, we'll go with the type called type 2, slowly changing dimension type 2. For example, you wanted to maintain only the current and immediate, only previous version alone, not older, all older versions. For example, that is the chance in this second type, slowly changing dimension 2. If the product price started with 10 rupees originally, then it has been changed to 20, then changed to 30, then changed to 40. Now it has reached rupees 100. The same product P1 have reached rupees 100 now, today. That could be, there could be a chance of doing that. So if that is the case, you will see how many versions, the version will be keep on increasing, and you may maintain 0, 1, 2, 3 up to 9 versions for 100 rupees. So if you just think in that way, right, if you want to go to a older version, we can filter that version and see when initially it was started with how many rupees, then after several versions it increased to how much amount. Maybe you can maintain the date also, the date of commencing or date of ending also, the expiry date and the starting date also. That is another way what is being used in slowly changing dimension. There are different ways used actually. You know, there is a way called flagging, or there is a method called date maintenance, or you may be maintaining the versions. So what I'm going to show is version. Maybe like in a later point of time, I can show you how to maintain the date also. Anything is fine actually. You have to mention any one of the method what you have followed actually. So we are going to see type 1 and type 2 in our coding actually. So that is what the overall concept I want to bring over here. So how do we implement slowly changing dimension 1, slowly changing dimension 2 in your using your Spark or Hive program is the overall concept what we are going to look into. So I park here and again I'll start with the hands-on part of it maybe. So fine guys, I'm going to continue talking about the hands-on part of it. Okay, so let's think about how to implement the slowly changing dimension 1 primarily using Spark. Okay, so it's a pretty direct concept. Just spend some time on understanding it. Okay, so just as a as a purpose of reminder, right, I'm showing you whichever the data you are going to get on a daily basis, you have to get it overwritten in the target site. So for example, if your product prices keep on changing maybe once in a week or so, you have to retain only the current price. You don't have to maintain the historical information. That's the concept behind the slowly changing dimension type 1. So I'm going to explain about how we can implement that in Spark. Okay. So I have this SCD code 1 provided to you guys, right? I just tweaked it a bit as per a better understanding. So we just see here, you can go to this folder. Maybe you can form the folder structures and all as per the code what we have. So for example, let me open the code. So this is the code for your reference, right? So SCD1 code what I'm showing here, okay? So you are going to include all Spark sessions or SQL, DataFrame reader, or all sort of the required libraries you are going to include. The SQL types I'm including for a reason behind, you are going to use the struct type actually here. So that's the reason. Maybe, okay, fine. So I'm creating an object called SCD1 inside object.inceptors.scd project, okay, a package. So I'm creating a main method. This flag I'm setting for controlling purpose. So if you want to pass this as an argument, you can have a single program, SCD1 and SCD2 in a single program to pass an argument called SCD flag 1 or 2. So just I'm maintaining or hard coding this value for now. Even you can pass it as an argument. So args of 1 you can take, or args of 0 you can take. Make it as an argument that can be passed over here as well as for a program. But just I'm hard coding it. I'm going inside. If SCD flag equal to 1, I'm going to proceed with this program. Okay. So let me just check. I'm just doing a builder pattern. I'm using a Spark session concept. Application names, simple sample, maybe like I'm going to make it as SCD1 app. Master of local of star and getter create I'm doing. Okay, creating the Spark context, SQL context. In the sense, this might have created the Spark and SQL context in the name of Spark. I'm just expanding that in the name of SC and SQLC for the better usage. So it will be very easy for me to use. Otherwise, I have to always mention rather than SQL-C, I have to mention Spark.SQL context dot implicits. So I'm downloading all implicit library because you remember to convert to data frames or to convert data frames to RDDs or create data frames and all, you have to download or import this implicits. Logger level setting to error level. I'm creating some schema, which is a struct type of type integer of, ID of int type, exchange, company, timestamp, and value as per the data. So this is the data I'm going to get actually from the source system at any time. For example, if you see here, I have a folder called SCD Code, and inside that I have a subfolder called SCD1. This SCD1 contains two components here. One is data. This is a blank folder, okay? And this is going to be your new data, which is going to come in on a daily basis. Maybe in this SCD1, you may get this new data 1, 2, 3 like that on a daily basis. Assume you are going to get this data for now. So this is the first time I'm going to load this data. This is the first time I'm going to create a maybe like the stock exchange information into my Hadoop platform. So if you just look at this, you have a data set like this: ID, exchange, company, date, and then value. So like this, you have some data set. Okay. So if you just look at this, you can see I'm just creating a struct type accordingly. So ID, exchange, company, timestamp, and value. So just for a better meaningfulness and all, I'm just doing this. Okay. So spark.read option infer schema true I'm making, delimiter as command, header it is invoking from the data sets itself, and I'm applying the schema by passing to this struct type. So this will become a complete data frame. Since I'm just calling the struct type, even you can avoid the struct type, you can directly go and infer the schema, and you can bring the name from the data sets itself because you are using header true. It's not a mandatory part I'm saying, but you can control. If you want to define the data type accordingly, you can control as well. So it's up to you to use accordingly. Okay. So I'm going to create two data frames. One is DFSRC1 and DF new one. So this is the one which is going to explain you more in detail. So this DFSRC1 is going to have the historical data. But right now, we don't have historical data in this data folder because this is the first time we are going to run. So we can't expect a historical data here. But in the second case, if you consider, DF new one is going to have the current or going forward data. You can expect either in this folder, this is a file I directly mentioned, even you can put it inside a folder for a better case actually. Let it be a file for now, okay? So you can have new data one, which is a daily file you may be receiving in the name of new data one, or you can keep it in a folder with any name if you want to get, okay? I'm just creating one more data frame to invoke this new data on a daily basis. So if you just look at this, if I have some data in the historical location, it may have this data frame loaded with some data. But new data, obviously, I may get for the first day or going forward also. I may not have this historical data for the first day. Maybe going forward, I may have some data in this folder also. Right now, we don't have any data in this folder because this is the first time we are running. But here we have some data in the name of new data 1.csv or whatever it may be. So this data frame will be loaded with set of data what I have shown you earlier in the data set. So I'm going to create two temporary views, right? Regardless it has data or not. So SRC1 temporary view will be stored in the name of initial data. DF new one, which is a data frame, which will be stored in the name of incremental. There are two tables I'm just creating, or temporary views that I'm creating. I'm going inside the try block because I want to just enable some exception handling and all if in case any exception occurs. Incremental load I'm going to primarily do. Okay. What is an incremental load? I want to keep on add or load the data by incrementing with what I'm getting on a daily basis. Okay. If the DFSRC1.RDD is not empty, that means I'm putting a not symbol here. That represents what you know. the historical data is available. That means if DFSRC1, which is created as a part of a historical data load, you can see here. If you have some data in this folder of data, obviously this data frame is going to contain some data. So what is going to happen here? It will check for whether it is not empty. If the DFSRC1 is not empty, it will just print in the screen saying like historical data is available for SCD1, slowly changing dimension 1. So it will go and quickly read this data and store it into a historical data frame actually. So even you can use this DFSRC1 itself, but I'm just doing an SQL query and storing that result into history DF1. Just printing that in the screen also, just for your information. Okay. Then I'm going to check if I have, this confirms whether I have historical data or not. But maybe for the first time, this will not show any data. This will not go inside, even I'll not go inside even. In this if condition, I'll not go inside. If this if condition fulfills, I'll go and check whether new data is available or not. Okay, there may be a chance you may have only historical data, there is no new data. But in this case, if historical data is verified, new data will be verified. New data is there, then it will get from the incremental data and store that data into, and it is displaying just that data frame, new DF test into your screen. So either historical and the current data is being loaded into the corresponding data frames and shown to you in the screen. So now what I have to do, assume like this new is going to contain the current data what you are seeing here. This is the new data. If I have any data inside this folder, it will show the historical data, but right now we don't have any data. So the case is, this case will not work for the first case. Though I explained this concept, this if condition will not work. You have to obviously go to the else case. Else case is all about what I'm going to do. Since I don't have a history, right? I'm loading the initial data as history. So for the very first time, it will directly go to the else case. So if you run this program right now, it will just identify only new data. There is no historical data available. So what happens here, it will go and check if historical data is empty. So it will not go inside any of these cases, will not be executed. It will directly come over here and go to the else case and say, no historical data to process for SCD1. I'm just loading the initial data as a history. So you can see here, I'll be doing df new one dot, that is the new data what we got. I make it as a single file, collage of one single partition, write that option header true because I want to maintain the header also in the output, overwriting to the target location, which is nothing but the historical data location. So today's data will become tomorrow's history. So this is the first iteration completed. What happens? This data will be loaded inside this data location. As such, Spark will take care of doing that. Okay. Tomorrow I'm going to get a new data set. Here I'll open and modify this data to make it as a tomorrow's data, for example. Then what will happen, we'll see. Okay. So first we'll see this concept actually. You have only new data, there is no historical data. What happens? Okay. Let me run this program. So it is going to fetch this data and it is going to check for any data present in this data location. No, nothing will find. So it will not go to the if condition. It will go to the else case, and the else case you have only historical data. This data will be loaded into this location, the data location. That is what going to happen. You can see it in the console. So no historical data to process for SCD1. Loading initial data as history is happening. You can just go and see here. This data have been copied inside this data location. Are you seeing the path file created? When a single file it is created, you can see that exact historical data, whatever the new data, exact new data has been loaded as a history. Maybe like the column name I modified, DT date I'm modifying as something called timestamp. Okay, so the column name I modified according to the struct type what I have defined. So you're finding one New York Stock Exchange, ID is one New York Stock Exchange, Intel Corporation on this date, the stock price was 610.66. Maybe the closing price you can consider. For in the same New York Stock Exchange, Walmart is having around $310. Okay, so this is how the original data has been generated. Now what I'm going to do, I'm going to modify this new data. Maybe you can consider this data is generated by some process. Now we are going to have one more stock exchange is added. So NYSE, New York Stock Exchange only. Maybe I'm having a product called, maybe I'm getting a new company called, maybe like AT&T is added. AT&T is added on the date of 2019-01-03 with an amount of $510.12. And on the second day, when you get this data, maybe that is on 3, the same Walmart and Intel has an increase in price or decrease in price. Maybe Intel have gone to $640 and this guy Walmart have got down to $10. So I'm changing these values accordingly. So you are seeing there is a change in the existing values and there is a new addition happened as well. So what is my aim here? This change has to be reflected in my existing data and a new addition also has to be loaded into the target. Maybe we can do like this actually. I'm going to exclude one of the, there is no Intel information is provided to me today. Today I have only the change happened only on the New York Stock Exchange and only on the Walmart and the AT&T. I don't have ID1, anything happened, okay? I'm not getting the data at all. So in this case, what happens, you can just see this value will be replaced with the original data, the historical data, what you have here. For example, this 310 will be replaced with what number? 300. And the new entry will be made over here in the historical data. You can see this 3 will be added, but this original one will not be touched. So what is happening here? We are not going to update this value. We are going to take our new data set and we are going to check whether which are all the IDs are present in the existing data. Maybe 2 is present. I will just take this new data 2 and I'll replace with this value. That is what I'm going to do. I'm not going to update in fact. And whichever is not present in the new data, that is 1. I will take that from the historical data and I'll take new data from here. Historical data I'll take 1 and I will leave this data set. The second one I'll leave it actually. This one I'll leave it totally. But if you just see this one I'll be totally leaving. But in my program I have to handle in that way. But I'll take these 2 from here, from the new data, and the original one, whichever is not present in the new one, from the old data set. This is how I'm going to do actually. So now final historical data is going to maintain, our final data is going to be stored with 1 with this value, 2 and 3 with these 2 values. So it will be showing to you like you got 1 retained, 2 updated, and the 3 has been inserted. Like this you'll be feeling, but actually speaking what I'm going to do, I'm going to use some left outer join concepts and all to ignore this 2 and to retain only this 1, and I'm going to add this 2 and this 3 over into the target. So that is what I'm going to show, what I'm going to do here. So if you just look at back, so you can see here I'm just collecting the historical data. This is going to load with what data? This data. Now you have the historical data like this, right? This will be loaded like this. You can see something like this. It will be loaded here. In this data frame, you can see this data now. And in the new data frame, you can see this data because this is the new data that I got today. You will see this data will be loaded over here. So this 1, one New York Stock Exchange. This is going to be loaded into this data frame, history DF, and this 2, 3, and all will be loaded into this new DF test. Okay. With these two data frames, what I'm going to do, I'm going to do a left outer join actually. So you can see I'm going to do a left outer join of saying whichever the initial data, that is the historical data, I'm going to do a left outer join with the incremental data, that is the new data that we got. Based on the ID, I'm going to check actually. So if you see, I'm going to join with this ID and the above ID, what it is going to show. If I do a left outer join between these two IDs, and I'm going to check where the incremental data.id is null. So that represents what you know. This history DF filtered will show only the historical data. That means the one alone will be taken, two will be ignored, because you can see two is going to match actually. So two will not be null. The ID 2 will not be null in the case of incremental. But which one will be null? One will alone have null, because left table will have, the historical table will have 1, but the right table, that is the incremental table, is not having 1. So that ID alone will be shown as null if you just look into it. That is what going to happen actually. So since it is like this, you can see I can't show that result here, but however, you can see something like this. When it joins, right, it will show something like this. The history DF filtered will show a value of this one value. So it will show something like this. I.ID will show a value of 1, comma, I.exchange New York Stock Exchange, Intel 2019-01-02. Since I'm not getting today, I'm retaining the old one. 610.66 is the amount. Okay. With this one, if you see this is the left table, which is nothing but the history table. If you go and see the right table, for example, let me make it in the down. It will be more meaningful. So if you look at this left table is going to contain this data, and the right table related to this is going to have null for the ID. So now I'm going to say whichever the o.id contains null, that means whichever is not matching in the right side, those data alone I want to fetch over here. So it will fetch only this first record alone. But whereas for the other case, if you just go and see, for the second record and all, it will have the value. You can see the left side will show like this. And the right side, if you see the right table, it will have this value. So the ID will not be null in this case. The second record ID will not be null. But whereas in the first record, ID will be null. That means o.id will be null, because today's data, incremental data, is not having ID 1. So what happens in this case, since I'm filtering only ID is null, what happens? Only this record will be fetched. I'm fetching only that record over here. That means I'm fetching from the history data only this record, whichever is not comes today. Whichever ID is not coming today, only that data I'm fetching from the history data, and this data I'm not considering at all, because this one I have to fetch not from here, I have to fetch from here. So simply say I'm ignoring all the data whichever comes today. That's what I'm doing here, and I'm taking only whichever I have originally. So 1 is not coming today, 2 has come today, so I don't have to consider 2 today. I have to consider that from the new data, not from my old data. So in this history filtered, DF filtered, I'm ignoring this guy, because this has come today. I have to take not 310 value, I have to get 300 value. That's what the concept behind. Okay. So since the value, the right side table, that is nothing but the incremental table, contains not null value, I'm not fetching that not null here. I'm fetching only the null here. So it will fetch only the ID number 1. That's what this history DF filter will do. I'm printing that as well in the screen just for your information. So now what I wanted to do, I want to take the history plus the new data. That means what you know, history is going to have only this 1, right? And the new data is going to be blindly fetched. This is the new data. So 2 with 300.19 will be fetched, and 3, that is a new data, will be blindly fetched, and I'll do a union operation. So history filter will have only that one ID, this data, and new data is going to contain these two data sets. So I'm going to finally get a new DF with what, all the 1, 2, and 3. 2 and 3 from today's data, 1 from the old data. And I'm just catching it. It is not needed really, but just doing a cache, counting to show maybe like how much count it has. Or I mean, since we are performing count and writing operation, I'm caching it. Maybe you can consider it that way. Then I'm coalescing to 1 and writing it into the historical location. If you just see here, I'm writing finally to the historical location. So now the existing history data, part of history data with ID 1 and the new data with 2 and 3 will be loaded into the historical data location. Tomorrow, if I get some new ID, it will be happening in the same way, in a cyclic way. That is what I'm going to show in this case. Let me open the data and show you. I have a historical data with this data set. And this is the historical data which contains ID with 1, 610, and the value with 310. And the new data that I got, right, where today I did not get 1, so I had to return the 1 from the historical data. But today I got 2 and 3. Though I have 2 in my historical data, I have to ignore this because today's data I have to replace this old with. That is the concept behind. So the new slowly changing dimension is applied here. You can see here 310 is going to be replaced with 300. And then the third value that I got newly today, and that I am also going to load. So if you just look at this, this program is going to now go to the if condition, not to the else case, because we have some data in the historical location. This is the historical location. So you can soon see this data will be replaced with a new data set, the data folder. So historical data is available for SCD1. What is the historical data? You have seen from the original file. And what is the new data for reference? That is 2 and 3, what we got today. Excluded data, that means historical data excluded with 2 and 3 because 2 is matching. The matched data I will exclude. So only 1 I am taking in the history. But history plus new data is going to take this 1, and then the new data of what I'm getting today, 300.19 not 310. If you just see this data I ignored, but this data I have taken into consideration, and I'm loading 1, 2, 3. The 2 is loaded with 300, not with 310. Old data I ignored. Old data I did not update it, but I ignored. So since I could not able to do update in HDFS easily, I'm ignoring and I'm taking the new data. This is the concept behind. This is the cache behind this particular use case. Okay. So what you have to do, you have to finally see in this folder, the historical data will be refreshed with today's new data and the old historical data. Are you seeing the historical data refreshed with the old data, but the new data has been loaded. Date 3 data has been loaded. This date 2 has been updated to date 3, not really by with an update. Rather, we follow some workaround. What we did, we ignored this data and we have loaded with the new data. Or we filtered the original historical data, which contains 2, and we load with the new data. That is what the concept behind altogether. Hope you are able to understand, but try to understand the concept of left outer join, and then you can able to understand this very simply. Maybe slowly changing dimension 2 also I have to discuss, but since I'm getting a bit late, right? So tomorrow I'll put one more video for discussing about SCD2. Okay. Thanks. So if you guys have any questions, you can raise it in later point of time. Thank you.